Okay, so this video looks at special right triangles. This seems to be a major area of concern for a lot of the students. They seem to have trouble with special right triangles and figuring them out. Special right triangles, there are two of them. The first one we're going to look at is a 45, 45, 90 right triangle. It is an isosceles right triangle. Okay? An isosceles right triangle. This always has the ratio x, x, because the angles are the same, so these two sides have to be the same. And the hypotenuse is always x root 2. That's a general ratio, right? So in general, if I have an isosceles right triangle, and this is 2 and 2, this has to be 2 root 2. If I have an isosceles right triangle that is 4, 4, then this has to be 4 root 2, right? So you can see the ratios can make this very easy. If I wanted to go backwards, sometimes they give you the hypotenuse. Let's say this was 6 root 2. Well, then these have to be the same, so they're 6 and 6, right? I'm getting smaller, so what am I doing up here? When I have this side of 2, I'm multiplying by root 2, and that gives me 2 root 2. Well, I'll use a dot for multiplication. To get from the small side to the hypotenuse, I multiply by root 2, and I get 4 root 2. If they give me the hypotenuse, I'm going smaller, I divide by root 2, which makes them cancel out, and I'm left with just 6. But what seems to be the trouble is when we have numbers that aren't quite as nice. And so what I want to emphasize is that a special right triangle is really, if you can remember that these two sides are the same, then you can do Pythagorean Theorem, right? Note those two sides are the same. So here's an example where I give you this information. And I say this is 3. So you know this is 3. And that's the one you need to figure out. So what you would do is say 3 squared plus 3 squared equals x squared. So what does that give you? 9 plus 9 equals x squared. 18 equals x squared. So the square root of 18, square root of x squared, well, that's 9 times 2, so that's 3 root 2 equals x. So with that being said, let's look at a slightly more difficult problem. What if my triangle had the sides 2 root 2 and 2 root 2? So what would I do if that was x? Well, I'd say 2 root 2 squared plus 2 root 2 squared equals x squared. When you square a number like 2 root 2, you have to, it's 2 root 2 times 2 root 2, which is 4 root 4, which is 4 times 2, 8, or 4 times 2, right? 4 multiplied by 2. So this is also 8, and we get x squared. So we get 16 equals x squared. Take the square root of both, and you get x equals 4. Okay? Now when we're going through this, maybe you want to try some of this on your own. So if I give you the triangle here, and I say this is 5 root 3, I want to know what this is. That's the type of problem you might see. And maybe I put a 45 in here and don't tell you that they're congruent. You need to know that this is the same. So for this, maybe pause and try to figure this out on your own paper, and then start it again and see how I work it out. All right? 5 root 3. So I have 5 root 3 squared in parentheses plus 5 root 3 squared in parentheses equals x squared. So 5 squared is 25 times 3, which is 75, plus 5 root 3 squared, which is 75, equals x squared. So what is this? This is 150 equals x squared. Okay, so take the square root of that, and this is a little bit more of a difficult problem because you have to deal with a larger radical. That's 25 times 6, $1.50 is 6 quarters, right? So that gives me 5 root 6 equals x. There's your third side. So if you have trouble with the ratios, just know that a 45, 45, 90 triangle has two sides that are the same. The hypotenuse isn't equal to another side, right? The two sides opposite of the 45s are congruent to each other. So you know that. What if I get a problem where I give you this, and I'll say that it's 10 root 3. Well, I know these two are 45s and 45, so this is x, and this is x. So I'll say x squared plus x squared equals 10 root 3 squared. Okay, well this is 2x squared equal to 10 squared 100 times 3 is 300 divided by 2 divided by 2, x squared equals 150. Well, we just did that one, didn't we? The square root of 150 is 5 root 6. All right, so that's how you do Pythagorean theorem with special right triangles. Special right triangles using Pythagorean theorem. If you knew the ratio, you could always say, oh, well, I'm going from the hypotenuse to the short side, so that means I divide by root 2. So 10 root 3 over root 2. Can't divide the 3 by 2, so multiply by root 2 over root 2, and you get 10 root 6 over 2, which is 5 root 6. And that's how you solve this special right triangle, by using the ratios, right? So here we have two different ways of solving special right triangles. Figure out which way makes the most sense for you, and then use that method, okay? So the second special right triangle we're going to talk about is the 30, 60, 90. The 30, 60, 90 has a 60-degree opposite of the long leg and a 30-degree angle opposite of the short leg. Okay, and the hypotenuse is opposite of the 90, of course. What you have to understand is that a 30, 60, 90 triangle is a 60, 60, 60 triangle that's been cut in half, meaning that the sides are all the same, except this one has been cut in half. So whatever this short leg is, this would also have to be the same, which means this is 2x and this is 2x. That way they're all three sides are the same. But this relationship about the short side and the hypotenuse, all right, the short side is x, the hypotenuse is 2x. That's always true for any 30, 60, 90 triangle. All right, so let's take a look at this this equilateral triangle, and let's say it's 8, 8, and 8. Well, let's drop a altitude there, cut it in half. That means this is 4 and 4. And so now we see that this has been cut in half also, 30, 30, 60, 60, right? So how long is this? Well, since it's a right triangle, you could do the Pythagorean theorem. X squared plus 4 squared equals 8 squared. And all you have to do, x squared plus 16 equals 64. Subtract 16 on both sides, and you get 48. Square root of both of those, and you get x equals, this is 16 and 3, so we get 4 root 3. So that kind of gives us a nice example of whatever x is, the hypotenuse will be x times root, or not the hypotenuse, but the long leg. The one opposite of the 60-degree angle will be x root 3. All right? And in this case, 4, 8, and 4 root 3. All right? So let's look at what happens. Let's make this more of a 30, 60, 90. Let's look what happens when I give you not so nice of a number. Let's say 5 root 2. Well, if that's 5 root 2, the hypotenuse has to be 10 root 2. And the long leg is x. What would you do? You would say x squared plus 5 root 2 in parentheses squared equals 10 root 2 in parentheses squared. So 25 times 2 is 50. That's 100 times 2, which is 200. And x squared plus 50. Subtract 50. X squared equals 150. We've done this a couple times. X equals 5 root 6. Alright? Pythagorean theorem. But again, you've got to know that relationship between the short side and the hypotenuse. The short side is half of the hypotenuse. The hypotenuse is the short side times 2. Alright? So let's look at one more. Let's say I give you this side, and we'll call it 9. Okay? So if this is 9, and that's the 60 side, the 30 side has to be x, and the hypotenuse has to be 2 times x, because it's twice as big. So how would you do the Pythagorean theorem with this? You'd say 9 squared plus x squared equals parentheses 2x squared. 18 plus x squared, sorry, what am I doing? 81 plus x squared equals 4x squared. Minus x squared on both sides. 81 equals 3x squared. Alright? Divide both sides by 3, and you get x squared equals 27. 27 is 9 times 3, so we get x equals 3 root 3. Okay? So this is 3 root 3. What's the hypotenuse? Well, it's 2 times that. So multiply the whole number 3 by 2, and you get 6 root 3. And there's your special right triangle. So again, I hope this, using the Pythagorean theorem, makes special right triangles much easier for you. You do have to memorize that a 30, 60, 90 triangle has a relationship of the short side x and the hypotenuse 2x. And if you can remember that part of it, then you'll be able to use Pythagorean theorem to set up and solve special right triangles that are 30, 60, 90. You still need to be able to recognize that any triangle with a 30 or a 60 that's a right triangle, you can use this with, and you should use this with. If you have 45, 45, 90 triangles, then you need to use the relationship x, x, and then use the Pythagorean theorem. Two sides are always the same, so make sure you get it correct. All right?